Imagine this. John is excited about his first programming interview. He's practiced for this in every way he knows how and feels prepared. Upon arriving in the interviewers asked John about one of the most famous computer science questions, the Knight's-Tour problem. Oh no! Despite all his practicing, John was still caught off guard. John begins to scratch his head for answers. Good thing we are here to help John. Okay, so what is the Knight's-Tour problem? The objective of the Knight's-Tour problem is to find a sequence of moves by a knight such that it visits each square on a chessboard exactly once. To demonstrate how this can be done in 2 steps, no less, we will use a graph representing the chessboard and an algorithm that finds the path connecting rows and columns for the knight's movement as it visits each square exactly once.
The first step in using a graph search to solve the knight's problem is to first show the moves a knight makes on the chessboard by using a graph. You can think of each square on the chessboard as being a single node in the graph. You can also think of each move the knight makes as being a single edge in the graph. We can then build our graph by using a function in C++. The function makes a pass across the entire board only once. The function will then call a helper each time it reaches a square on the board. This is so that a list can be generated for the legal moves for whatever position the knight is at on the board. Finally, we have to transform all legal moves into edges on the graph. A different helper function will then be used to change the location on the graph, which is shown by rows and columns, into a linear vertex number. You can use many different programming languages to build your graph, and your implementation may change. Just remember to have fun and try your best, Johnny.
The second step to solving the Knight's-Tour problem is proper implementation. In this step, we'll focus on achieving 2 goals. 1, utilizing a graph algorithm to make a path of length in the graph, and 2, instilling the condition that every vertex, i.e. space on the chessboard, is only visited once. In our problem, we are playing with an 8x8 size chessboard, which gives us 64 total spaces to tour through and 63 connecting edges. This can most efficiently be implemented through the use of depth-first search. Simply put, it allows us to follow the path of the edges and can find dead ends, which are places in the graph where there are no more legal moves. Depth-first search also actively uses colors. If a space in the graph has been visited by the knight, it'll be gray. If not, it'll be white. Yet another helpful feature. To prevent a space from being visited more than once, we'll construct a Knight-Tour function and make it utilize recursion. By doing so, we'll now recursively check the base condition. If the path contains 64 vertices, we have a successful tour. If not, we'll explore one level deeper by choosing a new vertex and calling the Knight-Tour function to it. Proper implementation is key to solving the Knight's-Tour problem. The better the graph is implemented, the quicker the Knight's-Tour problem can be run and solved.
Well, friends, there you have it. The Knight's-Tour problem explained to John. We hope this video helped your understanding of the Knight's-Tour problem and helps you in your programming interviews. Remember your algorithms. Till next time, keep coding.